Okay, I fixed that problem. I forgot to empty the recycling bin. Um, am I doing everything right? I am recording it. Let me see if I am. Show it. Where am I here? No. Good. Okay. I am sharing my screen. Good. Okay. So nested loops are possible again. You had a question. Does it make it more readable? And I would say no. For me, no, because I mean, if you instead of using this, okay, if you are using a compound statement, that means that you are going to put more than one statement in it. But if you use just a single statement in a compound statement with a single statement doesn't make much sense. So I see that it is not a good thing. No.
But in if as station, we see same thing. You forward the as station a bit left, and it is compared to if station
What?
without curly bracket. We
Indentation, you mean?
yes.
So what about indentation?
Yeah, without curly bracket, I think a bit confusing in if else station. If and one else.
Can you tell me which slide are you talking about?
Uh,
If statements?
yes, if else station.
Like this if else statements?
Yes.
Well, I mean, if you are talking about that multi-way if else statements, this is a special.
No, a bit left, a bit outside.
You mean
Up.
this? No, up.
Yes.
Yeah.
Yeah, in this
Yeah. It makes it confusing, yes, because indentation is wrong. I am not talking about. Oh, you mean this. You are saying that
yes.
if I used a
curly bracket,
curly bracket here, it makes everything more readable. That's
yeah.
what we are saying. Okay, well, I mean, you have a point in here again, and if somebody knows C very well, they don't have to put the curly bracket here, and they are very sure about it. And for these kind of cases, maybe you could use it. I mean, even though this if is a single statement, it's not a multi-statement. It's just a single statement, okay? You may prefer to use the curly brackets, but the correct way is this way. I mean, don't use it with the curly brackets, because if is a single statement, it's not a multi-statement. Well, it might be a compound statement by itself because it has two parts in it, okay? But it's a single statement, and compound statements are a block is treated as a single statement. Okay, so don't try to make your code more readable by adding more parentheses or curly brackets, because everybody knows the rules and they should know the rules. If you are adding extra curly brackets and parentheses, then it gets confusing after some while. Okay, good. Any other questions? Yes.
If and else together is a single statement.
If what? I am sorry, people. I cannot hear what you are saying because this thing makes it very difficult to understand. Just say it louder, and people from the online audience, they cannot hear you. Say it louder.
So if and else together is a single statement. Right?
Sure, yeah. If is a single statement, it might have this. I mean, it is considered as a single statement. This for loop dot dot dot. Okay, this whole thing is just like a single statement. Okay. Why? Because I can put this, right? If something something, after that there is a single statement. So that's the point of the structured programming. You may get these kind of complicated compound structures, and you treat them like a single statement and you put into somewhere else that needs a statement. Okay. Good. Okay, we are now going to talk about file input in C++ using the new way of opening files and processing files. Okay, we are going to use stream insertion, stream extraction and stream insertion operators to read files, to write to files. Okay, and we are going to open a file, of course, and we are going to start reading it. Without talking much, let's look at the program itself. Okay, by the way, the chapter 12 is about file processing in C++. I think I'm going to skip chapter 12. Maybe the TA will come here and we'll talk a little bit about it. Maybe I will talk about it. For now, we are going to start talking about this file input-output. That doesn't mean that we are not going to talk about the file input-output much. We are going to talk about it, but you already know what a file is. I mean, to do file input-output, you should know what a file is, what it means to create a new file, read from the file, write to a file, etc. You already know this from C, okay? I am just going to teach you how to do these in C++, okay? So, which is not that difficult, and you are going to see and you are going to understand it. To do, why don't I show you the program itself? Let's say I have a file named player.txt. Player.txt is my file name. Okay, it exists in my current directory, and inside it, okay, I have the score and the name of the person, name of the player. This player, Gordon Freeman, did this score, 100,000 something, okay? So I can have many lines like this, but this is a very simple text file. And now I am going to read this text file and print it on the screen, or something like that, okay? So this is the program. It looks like I am going to use cout, cin, etc., right? I am going to use strings, and I'm going to use this fstream. Fstream means file stream. This is input-output stream, and this is file stream. To be able to use those files, you need to include this header file, fstream. Okay. So line number 4, again, using namespace std. I am going to use lots of stuff from the std namespace. My main function, 2 strings, 1 integer, and 1 fstream object, input stream. Okay. So this input stream will be my file. Okay, I will read stuff from this one, line 11. You see this? I am using the stream extraction operator. It's like cin, right? Okay, it's like cin. Cin reads from the standard input, but this one reads from the input stream. But where is the input stream connected? It is connected to this player.txt file. So I make this input stream an object. Then I open my file on this input stream. Now this input stream is connected to player.txt, and whatever I read from this input stream, now they come from the player.txt file. Input stream goes to score, okay. Then input stream reads 2 strings, first name and last name. Then I print them on the screen. That's it. So this cout is very the same cout that we used before. This input stream is like cin, but of course it is connected to the text file. So go to the documentation of fstream and see what kind of other things available. For example, this is opening a file. What happens if I like to create a file? Okay. I like to create a file, not open a file. What happens if I want to write to the file? Okay, so it's like this, okay. Closing is like that. And what other things you want to do? I mean, there is not much you can do with a text file actually. You create the file, you write to a file, you read from the file. For the text file, that's it, right? For the binary files, it is a little bit different. For the binary files, you read many bytes, etc. You seek You say that I am going to seek to this position and etc. That kind of stuff. But text files, it is not that difficult. You just open it and you just read it. And if you like me to do it, C++ F stream. I hope this, yeah, C++ com is good. F stream, by the way, F stream, C out, C in, and this input stream are kind of relatives, akrabalar. There is a blood relationship between them. Kan bağı var aralarında. That's really, I mean, they come from the same ancestor, and that's why they share lots of genes. I'm not making these up. This is really what's happening. Okay, so F stream is here, and these are the things that you can do with F stream. Okay, open a file, close the file, and operator extraction for the file stream. Okay, operator insertion. It looks like it works. Oh, okay. Sorry. So for everything, these are the. Let me talk about this then. This F stream is here, and this is input stream, this is output stream, okay? This is the file stream. Our CIN is an input stream. Our Cout is an O stream. O stream is output stream, okay? Input streams and output streams are maybe connected to the screen or the files. And we are going to see how we can do that kind of stuff. F stream is definitely a file stream. Let's go to this F stream. This is I stream, O stream, iOS base. This whatever I can have with these public member functions, they are all available for the F stream too. So when we look at this open, okay, when you look at this open has many parameters that you can feed in. For example, you can open a file for input, you can open a file for output, you can open a file for appending, okay, and you can open a, these are the options that you have in C actually. No different, okay? And how you do the mode, okay, this is how you do it. For now, I have used only this first part. I gave the name of the file. I ignored the second part. But if you like, you can add the second part. I am opening this for input and output and appending, okay? You just order them together. Okay, so this is how you, oh, it is, okay, I forget about this. I think you can, yeah, you can compile and run this here. Does it really work? So it is opening a C shell here. And, oh, this is very similar to my compiler explorer, right? I think they are using the same interface. So I have a C++ shell, and let's use the C++ 11 standard warnings all, warning extra, click, yeah, good. So optimization, did you check the optimization flags? No, you did not. Optimization, well, I mean, I am not going to repeat the same thing over and over again. You should check all of those. And then when I say run, it compiles. And since there is no file name test.txt, I think I am going to, well, what did it say? Oh, it created a file because it is for outputting, right? And it is the program terminated normally. It did not crash. I don't know what happened. This is not a meaningful program anyway. So that's a good, I mean, this C++.com has these example codes and you can modify them and you can run them. That's a very good source actually. And you can change your stuff. Good, let's go back. And this is how you do file input output. That's it. This is needed in your homework. Maybe your second homework, but not this one. Okay, any questions about? Yeah.
How can we read a string with a blank space at one time?
How can you read?
A string with a blank space like
Oh
name,
yeah, you are
letter.
saying that, okay. You are saying that since there is a blank between these two strings, I have to read it two times, like the scanf statement, right? How can I read the whole line? Well, you go to the documentation, okay. You go to the documentation, and there is a function named getLine, okay. It gets the whole line, and in that line you will have your white spaces. Get reads just a single character. GetLine reads the whole line. So you have all of that stuff: peek, read, okay, read block of data, and etc. Everything. Okay. So whatever you have in C, actually you have in here. It's just a matter of just reading, taking a look at this documentation, and you will immediately figure that out. So this must be that, or this must be. For example, let's look at the example getLine function here. Well, I mean, this will not make much sense with the. Okay, good. So this is using the getLine on CN. What did I say? CN and that file, they are relatives. CN has the same functions as that input file thing. Okay, so I am using the getLine to a character array, so they didn't use strings. So it is fully compatible with C. And it looks like this means that read up to 256 characters. That's the overload of it. Okay, so getLine has how many parameters? Yeah. Well, getLine, it looks like getLine doesn't take a string, it takes a character array. So it looks like it runs like C. Okay, good. And by the way, it returns an iStream. We will talk about this later. Okay, any other questions? Any other questions? No? Okay, then I will continue. So that's the end of this chapter. Whatever this chapter is, chapter number 2. Yeah, chapter number 2. We looked at the Boolean expressions. Well, these are very important branching statements. And I mean, if you don't know C, for those of you graduate students, if you don't know C, these are very important topics actually. I mean, they spent month to talk about the if statements and the loop statements and etc. Maybe more than a month. They are very important, but I assume that you already know these. So I skipped them, and I only looked at the differences between C and C++. And if there is some place to emphasize about C, I talked about it. Okay? So let me start the new chapter then. Our chapter number is chapter number 3 again. Is going to be very fast. We know most of the functions already. Actually, I think I will only say only a few things about functions that you didn't know. Okay, so in this chapter we are going to look at the predefined functions. Those are the library functions, the functions that you are writing yourself, and some scope rules, and that's it. Okay, so we are going to look at the functions in a different point of view actually. I mean, I see the function like a black box. Okay, there is a black box. Let's say I keep giving this example, but square root sqrt, let me write it correctly. Sqrt is a square root function. Okay, you give, it's like a black box for me. Okay, it looks like a black box for me. All I know is that I give a double to it and it gives me a double. Okay. Does anybody know how to take square root of a float by hand on paper? When I was at high school, I had a psychology teacher who made us, because in psychology you make experiments with people, right? You ask question and you take the mean of the question and you take the standard deviation. To get the standard deviation, what you need to do is take the square root of stuff, right? He used to teach us how to take the square root of numbers on paper, and during the exams, if you cannot take the square root, you would get a 0. I learned it from him. So I think he got his education in 1960s maybe. So in 1960s there was no calculators, only those rulers, you know, those calculating rulers. I don't know. So they used to take the square root by hand, but I forgot it now. It was very difficult, very difficult. So we don't know how to take the square roots actually. Nobody teaches you how to take the square roots by hand, manually on the paper. So we ask this function to take the square root and it returns it. So this is called information hiding actually. They hid all the information, all the details of taking the square roots, and we didn't feel any difficulty. We didn't feel guilty, right? Because we didn't know how it works. We just used it because that's how human brain works. That's called abstraction. Okay? We like to abstract things away. We don't want to know the details, because if we go into the details, there is no way that we can continue our daily life. Okay? I don't want to know how the car engine works just to take the public bus. For me to take the public bus, I go there and I pay the driver 5 Turkish liras, and it takes me from Gebze to the other side of the 5. What is that? 500T, world's longest bus line. That's true, right? I think they made it even longer. So how much do you pay to the 500T driver to go to the world? If 5 liras, okay? No, 8. You don't know? So I think it takes 2 hours or something to get to the end of the line. All it takes me to pay 5 liras to that driver and sit there, and it will take me all the way, and I don't care how he does it. I don't care where he goes, and I don't care how that engine works. That's a very complicated car engine or the bus engine. I abstracted things away. All I do is I just sit there, I read my book, I listen to some music and etc. So I abstracted it away because I have something to do at the other side of the city. Okay? Square root is something like that too. I give a double and I get the double back. So this is how we live. This is how our minds work. We try to abstract away the details. We like to think it like it is a black box, and it works that way. All the engineers work that way. All the computer science work that way. All the regular people work that way too. So why don't we use the same idea in computing or in programming? So they invented the functions. Okay, write functions that have very simple interfaces like the square root. Okay, they might be complicated, but they are simple to use. So that will make the jobs of new programmers like yourselves easier. So that's what we are going to do. Write simple functions that have nice interfaces. Interface means how am I going to use it, okay? That have nice, clear, easy to understand interfaces, and they run efficiently, and when they come back, they gave me the result, like square root or sine or anything like printf, okay? So that's the idea of functions, and we are going to take this idea of functions and we are going to generalize it. Because this square root needs the data from outside world, and the idea is with the object-oriented programming, why don't we do this? Whatever object or whatever variable I am using, it has all it needs in itself. Okay, it has all the functions that is necessary. It has all the data that is necessary. All I am going to do is just make a simple function call, okay, without giving much parameters. So abstracting the details of this function plus the abstracting the details of those variables that is used inside those functions, etc., will be our task, and this will be clearer when we talk about classes. So we used in C the abstraction of functions, and that's what we did. There is an input, there is a process, and there is an output. Okay. So that's the basic building blocks of programs, those functions in C and C++. We learned about it, and they still exist in C++. The thing is that in C++, we don't like writing or using global functions. Okay, that's why we don't like printf. That's why we don't like scanf. That's why we don't like this global open function. Remember the open function that opens a file? We don't like that function because it's a global. Okay, so you might say that, how about the main function, int main? Isn't that a global function? Yeah, that's true. But as I said, C++ is not a pure object-oriented programming language. I mean, it has a one big promise of keeping the backwards compatibility with C, right? So to be compatible with C, you have to have main function as a global function. But other than the main, they tell us that don't write any global functions. Always use classes, and if you are going to write classes, you are going to write your functions for your classes. I think yesterday somebody asked me, maybe that person, our student is here or not, he asked me, so these classes, they look like, I mean, this code that you are showing me, here, the code that I am showing you, is like, this is like a struct and this is like a function, I mean, this is like a member of the struct. So they look like very much like structs. Are classes like structs? And I said yes. The difference between classes and the structs syntactically is that inside the structs we cannot have functions. Inside the classes now we are going to have functions. So why do we use structs anyway? It's an aggregate data type, right? Whatever is related, I put them into the same struct, okay, and I make it available to everybody. With the classes, on top of that data, I put the related functions too. So it is plus functions plus the data. That's the abstraction, and that's going to be the whole story about the object-oriented programming. Okay, whatever is related as data, you put them into the same place as its functions, and that's why if you are writing a function, that function works on that data. It doesn't need parameters from the outside world. Okay, so you don't need any global functions. You don't need any global functions other than the main function, which is needed to start an executable program. Okay, go back to the book slides again. Okay, our predefined functions, the libraries are available, and if you like to use those libraries from C, which we are going to use some of them. For example, the math library of C was very nice. I have the sine function, cosine function, and etc. So to be able to use it, any C library is available in C++. All you need to do is include this header, but to include a C header, you put a letter C at the beginning. So remember, math was available. It is available for C, math header. So to be able to use this math header in C++, you put a C at the beginning. stdlib is available in C. It is available in C++ with this name, C stdlib. Okay. There is a C type, character type header available in C. To use it in C++, you put another C at the beginning, CC type. And you can use anything you like. But as I said before, for some of those functions, we don't want to use them. Some of them we have to, because how else you are going to calculate the sine of a number, cosine of a number, or square root of a number, okay? For those, you need global functions again. So how did they solve this problem in the other pure object-oriented programming languages or more object-oriented programming languages? I mean, how do they take this cosine of a number in Java without using these kind of global functions or methods? We will see it when the time comes. Okay, so for the CMAT library, I have the square root. You give a double, you get a double, and that's it. Let me show you this stupid program. Nothing new here. IOStream and CMAT. Okay, a constant, named constant here, cost per square feet, initial value, and I have 3 doubles. Prompting the user to enter some value. I get the value. I do this calculation, double over double, right? Area, and I take the square root of the area. I need that one. Okay, so this one uses a compute the size of a dog house that can be purchased given the user's budget. Okay, so per square feet it costs $10.50, and I ask the user, okay, how much money you have. They gave me the money. They said that I have $100. So per square feet it is 1050. So 100 over 1050 is going to give me the number of square feet, but I need to print out the one side of the dog house. So I need to take the square root length side, and after doing some formatting, I print out this statement. It's like this. Enter the amount budgeted for your dog house, $25. For a price of $25, so it is going to be square root of 25 over 1050. So the length of or height of this one is 1.54 feet on each side. So and 154. Again, very simple program. It just used the square root function from the math header, math files, math library. Okay. So other than that, many functions available. Absolute value, okay, it comes from the stdlib, okay. Long absolute value, float absolute value, okay. This FABC is actually, ABS is actually from the math library, okay. In the math library, everything is about doubles. They take double and they return double. If you see a math function that takes a long or integer, usually they are defined in the standard library of C. Power, again, it is in the math library. It takes two numbers, x to the power y, and it returns it. Okay, it takes two arguments, one of those functions. And here are some of them: square root, power, absolute value, f absolute value. Okay, so this one, and this one, they are in the math header. Okay, these two are in the stdlib. Okay, again, double, 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 double. Okay, these are all math library stuff. Ceiling of a number, floor of a number. Exit is defined in stdlib. Exits your program. What? My network is not good. Well, it's not my problem. I think it's the university's problem now. Let's ask the people. Is my sound breaking? Can you guys hear me okay?
Hocam, your sound is not breaking, but if you close your camera, it will be good. It will be better.
Okay, I turned off my camera. Does it sound better now?
For now, everything is fine, I think.
Yeah, okay. So you won't see my picture, but you will see my screen, right? So I am recording this anyway. If you miss some critical stuff, I will post the recorded video to YouTube, so you can get it from there. So any questions from the online audience? No? Okay, let me do the raise hand test again. Everybody online audience, raise your hands, please. I will kick out people who don't raise their hands. So out of 50, 37, out of 59, only 39 people are raising their hands. So 20 people are sleeping. Well, it's very early day, right? 40. What should I do? Maybe for some reason they cannot their hands. Okay, thank you. You may lower your hands. So at the end of the lecture, I kind of lost half of the people. Okay. So exit is one of the void functions. It doesn't return anything. Okay, this is, I mean, usually a function, the meaning of function is this. Okay, you feed something and it gives you something else. Okay, if it doesn't give you something else, then it is doing something in it and it has an effect. So we call this a side effect. And exit has a side effect of terminating your program, right? What other functions do you know that has a side effect? Okay, typically this is the case. This is your function. You give data, you get data back, like sine or cosine or square root or ABS, right? Other than that, okay, other than its exit, what other functions do you know that has a side effect? I mean, it may return something, but on top of it, it is doing something else too. We don't like the functions with the side effects, because when you use those kind of functions, when I look at the program, I don't understand what's going on. I mean, I give something in it, I return something back from that, I see it for the sine and cosine. For the exit, it just function call, and after that, nothing happens. But I know the meaning of it because my program is terminated. That's the side effect. There are two other very popular functions that has some side effects that you have used a lot. Maybe those functions are the most frequently used functions of your C life. You don't know what they are? Yes? F-close, yeah, exactly. Yeah, yeah, it is one of them, really. You give a open for the same sake, right? You give a function name and it closes the file, and you don't see the effect of it from the returned value, but under the hood it does something. It just returns, it just closes the file. Open is the same thing too. What else?
Type of void functions. Maybe.
What is that?
Type of void functions.
Yeah, so that's what I am asking. I mean, what are those?
Main function.
Main function, well, you write it, it's not a standard function, but it behaves that way. Yeah, that's true. But how about this one, printf? Printf has a side effect, right? What is the side effect of printf? It takes some parameters, okay? It prints something to the screen, that's the side effect of it, and it returns an integer. What does it return, the printf? What does the printf return? Do you know it?
1 or 0.
No.
Character number.
It returns the number of characters that it has printed to the standard output. It returns something. So printf, I mean, when you look at it, it takes some parameters and returns an integer. But usually, I don't call printf to know how many characters it printed on the standard output. I call it to print something to the signal. So I am after the side effect. So you will see these kind of problems or these kind of concepts in the programming languages course of your third year. That's called side effect. Okay, so these void functions are usually they are called for their side effects. Okay, so programmer defined functions, if you have an idea, you will say that, okay, this makes a nice black box. Black box, I will give 1, 2, 3 parameters and I will take one result out. So I'm going to make this a function so that other people, including myself, can use it in a reusable way, and it will be as nice as the power function or the sine function or square root functions. The network quality. Okay, maybe I will try to speak slower then. These programmer defined functions are a way of abstracting away the details from your customers or from yourself. What did I say before? Your best customer is yourself as a programmer, because who is going to call your functions? Most of the time you will call your functions. Okay, and we divide and conquer. We divide our main program, main problem into smaller pieces. Each piece is nicely defined, and for each piece we write many smaller functions, and each one will take parameters and they will return values. And we are after the readability, reusability, and that's how we do stuff. So again, you know all of this stuff. I am not going to talk much. I have few function definitions here. Instead of doing that, I will show you this simple program. Let me take this out from this part to this, so that I'm going to talk about it in a few minutes. So I will have a function that takes 2 parameters, one integer and one double, and it returns a double. Okay, total cost. What does it do? It takes number parameter and the price parameter, the tax rate. It multiplies the price with the number. So I am selling stuff. Okay, let's say I am selling pens. Each pen costs 5 Turkish liras. Okay, if I sell 10 pens, okay, 10 times 5 is 50, but I have to add the tax, which is 5% of tax. Okay, and I'm going to add it. So multiply the price with the number, that's the subtotal, multiply the subtotal with the tax, and add the subtotal and return it. Very simple function. It doesn't have any side effects, right? Very nicely defined, clearly defined. And if you like to write a comment to this function, you can write it in just 2 sentences. Okay? There is no confusion about it, and the parameters are nicely named because I know what they mean, and the return value is very clear. So that's my function, and it is written in the same file as the main function. But to make the main function work, okay, to make the main function work and compile, I need to provide this function declaration before the main function. That's what we did in our C programs, right? Okay, we provide the header, function header or function declaration before we use in the main. So it's a global function. We don't like global functions in C++, but we didn't see the classes yet. Is my voice still breaking up, people?
Yeah, for last 3 minutes. Yeah, hocam. It's breaking.
I don't know what is going on, because okay, well, anyway, so you will have to use the videos. You will have to go back to videos and listen to it. Listen to it in 2x speed. It is quicker. Okay, so I have to define it before I use it, and this is the main function. I have doubles, an integer, enter the number of purchased items, okay, number of, how many pens did I purchase? This many. What is the price for each one? This is the price. So I send these numbers to total cost function and I get the bill amount, fatura miktarı. And using these, again, formatting statements, I print that out. Nothing fancy in this program. I think this is the first time we've seen a user-defined function. Okay. In C, usually, okay, if you don't write this line number 3, okay, in C, usually it works, it compiles. Because in C, to be able to use a function, main doesn't have to see its prototype or the header or the declaration. Okay? When you make this function call, in C, C compiler tries to find a function declaration first. If it is available, then assumes that it is there. If it is not available, it assumes that there is a function, it will come later, okay? And I don't know how many parameters it takes. I don't know what kind of parameters it takes. And I will assume that it's going to return an integer. Okay? That's what it assumes. Okay? That's what it assumes, and it compiles it that way. If the linker finds that function, everything works. Kind of works. But in C++, if you don't include this line number 3, okay, whenever at line 14, whenever the compiler sees that line, total cost, if the function is not defined, it is not declared, then you will get an error message. That's why in C, remember, I bet you did this many times and you get amused. Without including the std library, your printf and scanf statements work, right? Without including the stdlib. It just compiles and runs, and it runs okay, because for the printf, printf returns an integer. I don't use that integer many times. And if you turn off all the type checking of the parameters of the functions, everything is fine. But in C++, the things are different. Okay. But the common with C way of doing things, we usually keep our functions, because these are our black boxes, remember? We are trying to abstract away some details. Our functions in a separate file, and for those functions, we write a header file, so that those functions could be used from different files. So let's say this is my file.cpp, okay? This file. So this is what I do. This is the total cost function. It takes an integer and a double. And this is the implementation of it, right? There is the mean in between. So I put this definition in a header file, totalcost.h, and I put this implementation in tc totalcost.cpp file. Okay, so I have a header file for this total cost, and I have the source code file, implementation file for the tc.cpp, and I compile now two files, file.cpp and tc.cpp. Of course, I need to include this tc.h from the file.cpp, right? So I have three files, file cpp, tc.h, and tc.cpp. This makes it more modular. Why? Because if somebody else needs this total cost function, they can include this header, and they can compile their code with this program. Okay, so I wrote reusable code, and I made it available for anybody to use it. Okay. Good. Any questions so far? I think I am out of my time because we were doing the 45-minute. Maybe, you know, I have 5 more minutes, right? Yes, I have 5 more minutes. Maybe I can take your questions in that time. Yes.
Can we include tc.cpp in file.cpp?
Well, sure. Yeah. I mean, you may. The question is, can I include tc.cpp from file.cpp? I mean, it is possible to include it. You may include anything you like because it's a preprocessor directive, and if it is compiled, it works. But that is not suggested. That's not a good thing because this is implementation. Okay, implementation should not be compiled with your customer's code. Implementation should be kept different at a different place because I don't want to be depending on the implementation in this file. I only care about the function declaration here. Okay, implementation is something different. If I change my implementation, this file doesn't have to be compiled again, right? You understand this, right? So let me. So how do I compile the system? I compile the system. I'm going to write it. G, this is, can I make this? I think I can make it 0.5. Yeah, it works good. So I am going to compile it G++ minus C file.cpp. This will compile into file.o, right? Then I am going to compile G++ minus C total cost.cpp. This will produce tc.o, right? Then I will say G++ minus O, let's say my prog, and then file.o and tc.o. These three lines of statements, command line statements. Okay. After doing this, I made a decision that there is something wrong. There is some improvement in the implementation of the tc.cpp. I am making it more efficient. If I change a single line tc.cpp, I just compile tc.cpp and I link it again. I don't have to compile file.cpp. Right? With your suggestion, if I include tc.cpp from file.cpp, then I have to compile file.cpp too. Right? Because it is included in there. Okay? Of course, if you change something in the header, tc.header, tc.h, then you have to compile both tc.cpp and file.cpp. But the headers are rarely changed. Most of the time you change your implementation. Okay? So we try to keep the header from the, we try to keep the header separate from the implementation. Headers and the implementations are kept differently at different places. They are nicely separated. This one is only read by the customer. This one is the task of the implementer or the programmer. And we try to hide this implementation from the customer. Customer doesn't have to know how the car works, right? Customer only needs to know there are two pedals, accelerator pedal and the brake pedal. That's it. I'm giving you the car example again. The customer has to know that this function takes two parameters, and the customer doesn't care how the implementation works. That's why I wouldn't include CPP from this file.cpp. Well, it is, I mean, this kind of thinking is the way that I like you to do. Always try to do stuff to see if it is possible or not. There are two sides of the picture. One is what is possible and what is not. That's a very important question. Is it possible? Can I do it? The other question is, should I do it? Okay. Usually these are two different questions. What is possible doesn't mean that you should do it. Okay? Including another CPP is possible, but you should not do it. Okay? So if I am not going to do it, why should I know that it is possible? Well, it makes you learn stuff better, right? You learn it much better. You know that why it is possible, and you know why you should do it and why you shouldn't do it. So mechanism is something different than the philosophy of programming. You should know both the philosophy, principles, and the mechanisms of doing it. Okay, both of them are equally important. Okay, good. I think I am out of time right now. I will stop here and we will see you on Monday. Okay, bye.